This is section 3.5 of MA 104. For the indicated functions, we are asked to find, in this case, f plus g of 3 when we're given that f of x is 2 minus x and g of x is the square root of 3 minus x. F plus g of 3 is the same as f of 3 plus g of 3. So if I first find f of 3, that means instead of taking 2 minus x, I will take 2 minus 3. So f of 3 is negative 1. G of 3 is the square root of 3 minus 3, which is the square root of 0, which is just 0. We can then substitute these values back in for f of 3 and g of 3 in what we're trying to find. So this becomes negative 1 plus 0, which is negative 1. This time we're asked to find f times g of negative 1, which is the same as f of negative 1 times g of negative 1. F of negative 1, using the function that we have, is 2 minus a negative 1, which is positive 3. And g of negative 1 is just the square root of 3 minus a negative 1. That's just 3 plus 1, which is the square root of 4, which is 2. So since f of negative 1 is equal to 3, and g of negative 1 is equal to 2, I can substitute those values back into my original functions that I'm trying to find, which gives me 3 times 2, which is 6. To find the composition f composed of g of negative 2, this is the same as finding f of g of negative 2. So the first thing that I need to do is evaluate g of negative 2. Whatever that value is, I'll then take that and plug that into the function f. So to find g of negative 2, I have the square root of 3 minus a negative 2, which is the same as 3 plus 2, which is the square root of 5. So the composition f composed of g of negative 2, which we said was equal to f of g of negative 2, actually turns out to be f of the square root of 5, because I just replaced the g of negative 2 with what I found it was equal to, which is the square root of 5. Plugging the square root of 5 back into my function f gives me 2 minus the square root of 5. I can't simplify that any further, so this is my final answer. For the composition g of f of 1, again, that means, or the function g composed with f of 1, this means I'm finding g of f of 1. So I have to evaluate what f of 1 is, and whatever that value is, I'll plug it back into the function g. F of 1 is just equal to 2 minus 1, which is 1. So g of f of 1 actually just becomes g of 1. I took out the f of 1 and replaced it with what it's equal to. G of 1 is just equal to the square root of 3 minus 1, which is the square root of 2. So this is my final answer. I want to find the functions f plus g, f minus g, f times g, and f divided by g for these two particular functions. To find f plus g, in this case f plus g of x, I just need to take f of x plus g of x. F of x is equal to 4x, and g of x is equal to x plus 1. Adding these together, I have the 4x plus x plus 1, which simplifies to 5x plus 1. So the sum of the two functions is 5x plus 1. The difference of the two functions, f minus g of x, again, is just f of x minus g of x. We have to be careful with the subtraction that we are subtracting the entire quantity g of x. And what I mean by that is f of x is 4x minus that quantity g of x is x plus 1. I have to subtract each term in that quantity. So I have 4x minus x minus 1, which leaves me with 3x minus 1. To take f times g of x, I multiply the functions together. So I have 4x times the quantity x plus 1. This time I have to distribute the 4x, which leaves me with 4x squared plus 4x. And then finally, f divided by g of x just means taking the function f of x, which is 4x, divided by the function g of x, which is x plus 1. I can't simplify this any further, so this is my product, this is my quotient. We're doing the same thing with these two functions. I'm finding all four of these operations: addition, subtraction, multiplication, and division. So to find f plus g of x, I will take f of x plus g of x, which gives me 2x squared, plus g of x, which is x squared plus 1. Adding these together, I have 3x squared plus 1. To take the difference, f minus g of x, again, that's going to be f of x minus g of x. So I have 2x squared minus the quantity x squared plus 1. When I do that subtraction, I have to remember to subtract each term in the parentheses. So 2x squared minus x squared just gives me 1x squared. And minus a positive 1 just gives me minus 1. F times g of x involves taking f of x times g of x, which is 2x squared times that quantity x squared plus 1. If I distribute the 2x squared into the parentheses, I have 2x to the fourth plus 2x squared. Finally, f divided by g of x gives me 2x squared over x squared plus 1. I can't simplify this any further, so this is what I'm left with. For the operations here, f plus g of x involves adding those two functions together. So I have f of x, which is 3x plus 5. I will add that to g of x, which is x squared minus 1. Combining my like terms, I have x squared plus 3x plus 4. To take f minus g of x, again, I have to be careful about subtracting the entire quantity. So the f of x is 3x plus 5. I'm subtracting the quantity x squared minus 1. So I have 3x plus 5 minus x squared minus a negative 1, which is plus 1. Combining my like terms, I have the opposite of x squared plus 3x plus 6. For the product, f times g of x, this involves taking 3x plus 5 times x squared minus 1. I can think about this as repeated distribution of first the 3x and then the 5. 3x times x squared is 3x cubed. 3x times minus 1 is minus 3x. Then I'll distribute the 5. 5 times x squared is plus 5x squared. And 5 times minus 1 is minus 5. If I put these in descending order, I have 3x cubed plus 5x squared minus 3x minus 5. For the quotient, I will just need to take the first function f, which is 3x plus 5, divide by the function g, which is x squared minus 1. To find these compositions, f composed with g, if I want to find f composed with g of x, that just involves taking f of g of x. Well, g of x is x squared minus x plus 1. So what I really want here is f of x squared minus x plus 1. So I will go back to the function f, and wherever I see an x, I'll replace it with this quantity. I guess I could have closed those brackets there. Because I'm cubing the x, this becomes x squared minus x plus 1 quantity cubed. You don't actually have to cube that. You can leave it as the quantity cubed. To take g composed with f of x, I'm actually taking g of f of x, which means I am finding g of x cubed. So anywhere that I see that domain value of x in the function g, I'm going to replace it with an x cubed. So that gives me x cubed squared minus x cubed plus 1. X cubed quantity squared is x to the 6th minus x cubed plus 1. To find the compositions of these two functions, if I first want to find f composed with g of x, that involves finding f of g of x, which is f of 2x plus 3. So when I go to the function f, wherever I see an x, I'll plug in a 2x plus 3. So that means that I will have the absolute value of 2x plus 3 plus 1, which simplifies to the absolute value of 2x plus 4. To find the composition g composed with f of x, that means finding g of f of x, which is g of the absolute value of x plus 1. If I go back to the function g, wherever I see that x, I'll plug in the absolute value of x plus 1. So this gives me 2 times the absolute value of x plus 1 plus 3. To find these compositions, first I'm finding f composed with g of x, which is f of g of x. G of x is 1 over x, so I'm actually finding f of 1 over x, which, since the function f is x plus 2, the function f of 1 over x will be 1 over x plus 2. To find the composition g of f of x, that means finding g of f of x, which is g of the quantity x plus 2. Since my function g is 1 over x, I'll plug in the x plus 2 for the x, so I have 1 over x plus 2.